Welcome. Um, so the last time the world was so polarized about an advancement in technology was in the early days of the internet, when people were trying to sell things online, e-commerce and online shopping was becoming a thing. Many governments tried to shut it down, probably in good intentions because a lot of the people got scammed doing that. But now with proper regulations, we can't really imagine a life without online shopping. And then email and instant messaging and things like that allowed free flow of information that was breaking national borders. So I personally believe that humanity as a whole has an innate desire to forge a new path where there are no borders in the world. And internet has made it possible by allowing free flow of information without thinking about which country you're from or which country you're sending a message to. So just like a cross-border email is ridiculous, why shouldn't be a cross-border payment, right? So it's a good question to think about. So my name is Badi. I'm the co-founder and the chief product officer for Valor.com, and I'm here to tell you a little bit about blockchain and cryptocurrencies. When I started devising the title of this session, I thought 40 minutes is a good time to do a deep dive, so I called it a deep dive. But after I created the content for it, now I'm rethinking the title, and I want to rename it Scratch the Surface. But hopefully I'll do justice for your time. All right, so here's the agenda. We'll quickly go through the differences between cash and crypto. We'll see how decentralization works in Bitcoin. We'll compare a couple of consensus algorithms that are in the blockchain world. We'll look at smart contracts, and then finally we'll end with a few developer tools that you can use to build applications on the blockchain. Does this sound good? Okay, so I see a few nods, because earlier today I was speaking to one of the speakers, and he said he was so disappointed at the end of his talk because the whole 40 minutes he couldn't get any reaction out of the audience. And I said to him, maybe it's just the Swedish audience. And he said, no, like, what kind of reaction did you want? And he said, maybe a nod, a smile, and like, oh yeah, I have that too. But so please nod if you agree with me. So I'm just going to randomly ask questions. Are you guys happy with this agenda? Great. I think I'll be happier than that other speaker. Sorry for you if you're in the audience. All right. So cash versus crypto. Here's a question: how do you prove that the money that's in your wallet, the cash that's in your wallet, is actually yours? Good answer. How about your watch or shoes? So the assets, the physical assets that are in your possession, and you don't actually have to prove that it's yours, are one kind of asset called bearer asset. So you have it, that's why it's yours. But how about the house that you live in? How do you prove that the house that you live in is yours or not? The car that you drive is yours or not? Yes, in a repository, like a Git repository, right? No, I'm just kidding. So there are these. There's a second kind of asset. So any asset in the world actually can be divided into two. A bearer asset, something that you have, so you don't have to prove that it's yours because you have it. That's the bearer. And then there's a registered kind of asset where you probably be living in a house, but still there's a trusted entity that you go to say, to ask for who belongs, who owns this house or who owns this car. And when you want to transfer ownership, then you have to go through that trusted registry, trusted entity to transfer ownership. So generally when assets become digitized, it's very hard to, it always has to become a registered entity because the nature of digitized assets. Like if a photograph you have on your phone is sent through WhatsApp or Messenger, suddenly there's 2 or 3 copies of it. So we can't really know who owns the rights to that thing. So you have to have a trusted entity for registered assets as soon as it gets digitized. But what cryptocurrency has done for the first time in the history of humankind is create a digital bearer asset. So it's a digital asset, but you can prove to people that you have it by holding on to something. And that something, as you might not know, is called a cryptographic key. So using that key can be in your phone or on your computer, or in a file in your computer. So that you are the bearer of that key. And you are able to spend assets onto a blockchain network using cryptocurrencies as even though it's digital. So this has happened for the first time in the history of humankind, right? So how does it happen? How does it work? And how does this digital bearer asset actually work? So there are three main things. One is its decentralization, and second is incentivization. So the network itself is incentivizing people in a certain mechanism so that you can actually have a digital bearer token. And finally, cryptography. So using public-private key cryptography. So these three things, amongst many other things, game theory, whatnot. So it's a beautiful combination of different things coming together to create a new asset for humankind called the digital bearer asset cryptocurrencies. So let's see how this all works. So in order to learn blockchain, you generally have to start with Bitcoin. And so we'll look at how decentralization works in Bitcoin. So just a show of hands, how many of you are experts in blockchain technology? How many of you know a little bit about how Bitcoin works? Okay, all right. So you can leave the room now. No, I'm just kidding. All right. So let's start with decentralization in Bitcoin. So just a little bit of history, just going back 250 years. This, how many of you recognize this? Okay, you're showing your age. So Britannica was the way to get information back in the days. So this is a 250-year institution of the world. And they were creating information, creating knowledge, and sharing knowledge with people. And then came Wikipedia, just about 10, 15 years ago, and things changed completely. A 250-year organization became kind of obsolete. What exactly is the difference between these two? So the real difference between Britannica and Wikipedia is really in the way they create content. In the case of Britannica, there were about 400 people in the organization. They would go out, collect information, collate the information, make it into books and pictures and whatnot, print the books, go out and sell those books. Only the people who bought those books will have access to that information and knowledge. And the difference in Wikipedia was that anybody could access that information for free. Anyone could create that information, and anyone can consume it. At the end of the day, there are 270,000 active contributors in Wikipedia, and the speed with which the information gets updated is also phenomenal compared to traditional ways of doing information gathering and information dissemination. So what really happened here? What happened was a decentralized information system, as we call internet. So internet was a decentralized information system that allows free flow of information. Just like I said, like instant messages, email. You don't think about borders, national borders. It's free. Like you send, you don't care where the recipient lives, and it's pretty much free to transfer information and consume information. So that's what internet did. But what blockchain does is it takes it a step further. It's still decentralized, just like the internet, but it allows you to exchange value. So it allows free flow of value between people. So let's see how Bitcoin actually works. So this is a general ledger. A ledger is nothing but a record of money coming in and money going out, and balance updating. So 3 things that happen in a ledger. So money comes in, money goes out, balance gets updated. So that's pretty much what you see in your online banking statement. In the case of a centralized service, like a bank, your bank, whose ledger do we trust? It's the bank's ledger that we trust, right? Because they keep track of one database where money comes in, money goes out, and at the end of the month, they tell you how much you have left in your ledger. But in a decentralized system like Bitcoin, whose ledger do we trust? Because there's thousands of computers. Even though those images are of people, it's actually decentralized network of computers. There are thousands of ledgers distributed across the world. Whose ledger do we trust? Here there's one ledger to trust, one entity to trust, but there's a decentralized network of computers. Whose ledger do we trust? So blockchain is really the process of figuring out who gets to update that ledger that is shared across thousands of computers. So who gets to update the ledger? And that's the big question, and that's how blockchain technology solves the problem of digital bearer assets. So here are 3 things. This is what happens. Every 10 minutes, a block gets created in the Bitcoin blockchain network. A block is a fancy word to say it's a bunch of transactions put together. It's a block. And then who creates that block every 10 minutes? It's called the miners. These are all computers on the distributed network, but they are special computers which have a lot of computation power. So what they have to do is claim their right to update the blockchain with a block. And how do they claim their right? By solving a cryptographic puzzle. So there's a very difficult puzzle. It usually takes 10 minutes to solve, and it takes a lot of computation power. So they're solving and solving and solving and solving and solving. And finally, one of the miners says, I have solved the puzzle, and so give me the right to update the ledger. And then the rest of the computers actually say, yes, have you solved the puzzle? They verify that. They see all of the transactions in the block, whether it's valid, and then they let the miner update the ledger, and then it gets distributed. We'll look at it in a moment. So the more computing power that a miner puts in, the higher the probability that they will be able to solve that cryptographic puzzle to allow updating the ledger. So let's go through a process of computation and competition. So let's say all of these computers are miners in the Bitcoin's blockchain network. All of them have a shared ledger, so a copy of the shared ledger. It's the same copy. So then a bunch of people are sending transactions onto the blockchain network. And so all of these computers are competing against each other, trying to solve the puzzle. 10 minutes later, what happens is one of the miners says, hey, I've solved the puzzle. And here's a block of all the transactions that I want to add to the blockchain. So this cryptographic puzzle is asymmetric. What that means is that it's very hard to solve the puzzle, but it's very easy to verify that it's solved. It's just like Sudoku. Have you guys played Sudoku? Yeah, Sudoku is very hard to solve, but it's very easy to see that you've solved it. So you just go through it and it's solved. So it's asymmetric cryptographic puzzle. So once this guy says, I've solved the puzzle, the rest of the computers verify that the miner has solved the puzzle. And then in the block, they verify that all the transactions are actually valid. And if more than 51% of the miners agree, then this block gets onto the next block in the blockchain. And then they all share the new block. So that's as simple as that. So that's blockchain. So blockchain is really the process of figuring out how to update the shared ledger. And this mechanism is called proof of work. So why is it called proof of work? So the miner has to prove that he has put in the work to claim the right to update the ledger. So that's why it's called proof of work, and it happens every 10 minutes. So you can see, you can go to blockchain.info, and you can see real money is being transferred across the world without borders every single day, every 10 minutes. And you can see the second block here, $32 million with 2,448 transactions were transferred in real time without any financial institution being involved, and not one person clicking a button and nothing. So this is a new world that we are going towards, where like information is borderless, and why not money? Why can't money and value be borderless? So that was proof of work. But a lot of the people critique blockchain technology for a lot of use of computation power. Have you heard of that? Like some people say that to create one block in the Bitcoin's network, you use up as much electricity as one household uses in the US for a whole year. I don't know how much of it is true, but there are claims like that. In fact, some people say that Bitcoin's electricity consumption is more than Iceland or New Zealand. So people just come up with those things. But regardless, maybe that is a valid concern. So there's a new consensus algorithm that some of the blockchains, not Bitcoin, but some other blockchain networks like Ethereum, Cardano, Lisk, and a few other blockchain networks that are implemented or planning to implement, called proof of stake. What happens in proof of stake is that those special computers who were doing computation, they're not called miners anymore. They're called validators. So what the validators have to do is stake some coins into the blockchain network, the same currency that the blockchain supports. So staking is pretty much like depositing. So I deposit $10,000, so then I get the probability of me getting chosen to validate the transactions and adding the next block. Okay, so that's proof of stake. So the more money I stake into the network, the higher the probability that I get chosen as a validator. And if I get chosen and I create a new block onto the network, the way I get rewarded is by getting all the transaction fees for that block into my kitty. But there's a problem with that. So rich get richer, poor get poorer, right? So like if you have a lot of money, you stake a lot of money into that network, and then your probability is very high in getting chosen time and again to become the next validator. And so there is some kind of randomization in the algorithm to choose, not to choose always the highest staking computer in the network. So here are the differences. Proof of work, to add a block, you're a miner, not like a kid, but like a miner who mines the gold, you know. So a miner who competes to solve a difficult puzzle, and then they get a right to update the block. In the proof of stake, this competition is more of an algorithmic selection of depending on how much money you have staked into the network, because you have a stake in the network, and that's why you are given the right to update the blockchain. Then there is this malicious thing. So is it easy to hack a blockchain network? Right, big question. In proof of work, it's almost impossible with the Bitcoin's blockchain network to reverse a transaction or add a malicious transaction or do a double spend, like I've spent some money and then I spent another same money again. So it's pretty much impossible to do that on the Bitcoin's network because of the value, the amount of money needed to do that. Because here, you have to control 51% of the hash rate, the mining power, the computation power in the network. And the current prices of Bitcoin, that is probably around $100 billion. So if you have $100 billion, you will be able to try and attack the Bitcoin network. But on the other hand, for proof of stake, you have to own more than 51% of the currencies in the network to be able to do a malicious attack. But if you own so much currency in that network, it's in your best interest to keep that network actually safe and secure and running. So the very incentive mechanism that's built into blockchain lends itself to becoming more and more secure over time. And then finally, the reward that the miners get is, for example, in the Bitcoin's case, I'm not sure now, it's either 12 Bitcoins or 6.25 Bitcoins every 10 minutes, every block that is received by the miners. But on the other hand, there's no real extra reward that the validators get. They will get all the transactions fees that from the block that they have just validated. So are you all with me still? Yeah? Clear as mud? No? So no nodding. So I think I need to just see what else I can do to get you to nod. All right. Okay, so that's Bitcoin and how Bitcoin works. So with the success of how Bitcoin created this payments network, many people in the early 2011, 12, and 13 thought about, okay, if Bitcoin can work for payments, why not do the same thing for decentralized different applications wherever there are trusted intermediaries? Why don't we remove the trusted intermediary? Like how Bitcoin is has removed banks from the equation of payments. Why not remove trusted intermediaries from other applications? So there was this project called Namecoin that was proposed as a replacement for the DNS registry. And then there were other coins. So cryptocurrencies were popping up every so often to solve different problems. And then Vitalik Buterin and a couple of really bright-minded people came together and said, why can't we create a generic blockchain network that is programmable? So you can put any applications onto this, and you can do supply chain management, you can put academic records on there, land registry on there, trade finance, whatever you want. So long as you can write code, you can do it. In fact, Bitcoin also allows you to do smart contracts, but the APIs are very limited on how much you can achieve. But with Ethereum, you can really write proper code to meet your needs of a decentralized network. So, so what is a smart contract? Smart contract is nothing but code that runs on the blockchain. In this particular case, Ethereum blockchain, but there are other blockchains also that support smart contracts. But it's called a contract because it controls something of value. Whenever you sign a legal contract, it's because you're dealing with value. So similarly here, it's a smart because you can code it up. It's a contract because you're working with something of value. And what does it look like? So this is what it looks like. It's a simple contract, smart contract. So if it looks familiar to you, then it should, because it looks like JavaScript. This language is called Solidity. It's like the JavaScript of Ethereum contracts. But there are some differences, obviously, with this, because this code can be deployed to the blockchain. But by the very nature that it can be deployed to the blockchain, there are some unique properties. Those are, it's immutable and perpetual. That means once you deploy this code, you cannot take it back. And it will be running all the time. If you find a bug in the code, that's the end of it. So you can't control C or restart the server or whatnot. So this code gets deployed into the blockchain that's always running. And it gets reproduced into thousands of computers around the world, into a global runtime environment, and it also controls value. So that is why it's very, I compare smart contracts to almost like hardware programming, not software programming. So when you're programming software, it's fine to have a bug here and there, right? So you can always, if it's a catastrophic bug, you can stop the server, fix the bug, redeploy, restart. If it's a small bug, you can always redeploy and fix the bug and whatnot. But when you create hardware, once you print a circuit board or something, You can't take it back. It is what it is. So smart contracts are like that. So it takes a lot more thought and design to try and create smart contracts that work and are not buggy. So just as a trivia, there was something called the DAO hack that happened in 2016. So this is the piece of code that was part of a smart contract that had 1,000 lines of code. And this had a bug in it. Can someone find the bug? So while you guys are finding the bug, I'll tell you what the DAO was. The DAO actually means the Decentralized Autonomous Organization. So this was the time when Ethereum's value went up 1,000-fold. It was like cents, but it was like $10 or $20. So Ethereum was gaining popularity as a blockchain network that can do multiple decentralized scenarios. And this particular scenario was supposedly like a decentralized Kickstarter. Like if you had an idea, you would propose an idea, and people could vote for those idea and then actually fund that idea, and then you would fund your business operations using the funds that you received. So it's like a Kickstarter, but it's autonomous. No one actually is controlling. It's decentralized. So this idea was considered phenomenal revolution in fintech space. And so about $150 million worth of Ethereum was collected within the first few hours of this contract going live. But unfortunately, there was a bug in the smart contract. And as I said, the smart contract is something that you cannot take back. Once it's there, it's there. So this hacker was able to drain $50 million worth of Ethereum from the contract into his own wallet by exploiting that bug. Have you guys found it? Negative payment? Not really. So let me tell you. So this is the line that rewards. So like, as I said, this contract was supposed to, as someone deposited Ether, which is the de facto currency for Ethereum, and then as a reward, they would get the DAO tokens. You guys must be familiar with the 2017 initial coin offerings where you would pay some Ether or Bitcoin, or you receive some tokens back as an investment into some projects that are supposed to do very nice things on the blockchain networks. So this was similar. So you would pay Ether into this contract, and that contract would return to you some DAO tokens. But what the code did would give you the reward before taking away your balance. So this hacker, what he figured out is that he could write another contract where, as this contract was sending him the reward, he could call this function back before his balance was getting updated. So his balance was never zeroed out. So he went into a recursive call that kept on withdrawing money into his contract until he drained $50 million worth of money. Thankfully, the contract also had a 28-day waiting period before you could convert those DAO tokens into back to Ether so that you could sell it and then whatever. So the Ethereum core developers had about 28 days to figure out what to do. By the very nature of blockchain networks, it's supposed to be immutable. Once it's in, it's in. You can't take it back. So there were some proposals to say this was actually not just a hack, it was stolen. So let's actually do something to remedy this. And the core developers had to get involved. And so just to put it out there, this hack was not a problem with Ethereum. So just to give you an example, if a website gets hacked, the internet doesn't get hacked, right? So Ethereum was fine, it's still running fine, it was running fine. It's the smart contract that was running on top of the Ethereum network that got hacked. So just like a website getting hacked, not the internet getting hacked. So anyway, so Ethereum core developers came together, they asked the community, and that's another nature of decentralized applications. They asked the community to what to do, and most of the people said, let's roll back this transaction that created this contract. And a few people said, no, we have to be purist to the technology. We cannot roll back. We have to continue as is. So in any case, in 2016, so this is the this is the history, a short history of how the updates have been done on Ethereum's network. And this particular one was an unplanned fork. All of these were planned upgrades to the Ethereum network, but this was the unplanned fork that happened. They did an irregular state change where they rolled back the transaction that actually created the contract, and so that they could refund all of the money that was lost. But there were still a few people, the purist people, who continued on with the blockchain network that had the hack. So Ethereum was forked into two. So one is called Ethereum Classic. To this day, it still exists. And then the other one is called Ethereum. The value of Ethereum Classic is much, much lower than Ethereum as it is because of the number of nodes that supported Ethereum Classic. But this is what it is. So this trivia is very interesting and supports the fact that when you are coding smart contracts, it's not as easy as coding a website. You have to really put in thought and design into something you're designing. So, how much time do we have? Okay, so 8 minutes. So finally, I just want to give you an overview of all the developer tools that you can use to get your get your hands dirty with some of the blockchain development, create decentralized applications, learn about blockchain, and so on. So all you need is these. There are many, many other tools, but there are these tools that I recommend that you can get started with. So Ganache is something. So these are all in the Ethereum ecosystem. Ganache is a software that allows you to install a node locally on your computer, so you can interact with the blockchain network as though it's a network. While Infura is a software as a service where they run full node blockchain networks both on the mainnet and the testnet, and allow you to interact with their APIs to create blockchain-based distributed applications. Solidity is the language of choice for creating smart contracts. Truffle allows you to compile this language into bytecode and deploy into the blockchain, either to Ganache or to Infura. Truffle also has other ancillary tools like Drizzle and so on and so forth that lets you easily create front-end applications using React or Angular and so on and so forth. And then finally, MetaMask is a wallet tool. It's that allows you to interact with your distributed application once you create it. It allows you to maintain balances, send and receive Ether and other tokens right from your browser. And then the honorary mention is OpenZeppelin. So OpenZeppelin is actually really cool. It combines all of this together and allows you to get started within 5 minutes, gets all the tools necessary for you. There are starter kits for you to start working and creating smart contracts and deploying smart contracts and see how it works. You can interact with the smart contracts using MetaMask and so on. So if you just want to do one thing, I would recommend going to OpenZeppelin and just try it out for 5-10 minutes and see how it works. So in summary, so what we've seen is cryptocurrency as a new asset class that humanity has never seen. We saw how decentralization works in Bitcoin, smart contracts on the Ethereum ecosystem, and some developer tools to help you get started with creating smart contracts and distributed applications. So that brings me to the end of my talk. I think we have 5 minutes left. So I'm open to questions if you have any questions. And by the way, this is my Twitter handle, which is actually printed wrongly on the booklet. So if you want to tweet, follow, please do. Questions? Yes? Everything, okay. That's great. Yes? So most of the nodes moved to the rolled back version of Ethereum. So if you look at the prices of Ethereum and Ethereum Classic, that gives you an indication of how much computation power moved to one or the other. So Ethereum is around $200 and Ethereum Classic is about $10. So it gives you an indication of the value behind the network. Yeah.
What decides the actual value of, for example, Ethereum or Bitcoin? How do they decide the value of it?
Yeah, so the technology does not decide the value. It's the society that decides the value. So it depends on supply and demand. So most of that happens on crypto exchanges, like ours, Valor.com, so where we don't set the price of Bitcoin or Ethereum or any of the currencies. So if people believe, just like the money that you have in your pocket, what is the value of that money is dependent on how much of the belief system believes that it has value. So it's the supply and demand. But the technology itself is agnostic to the price movements. But there are some political, I mean, when it comes to money, it's influenced by policies, governments, and so on. So sometimes if China says we are going to ban blockchain, then the price goes down. If China says we're going to embrace blockchain, the price goes. So it's a geopolitical environment kind of influences the price. But in terms of technology, the core developers of Bitcoin, Ethereum, and many other blockchains are continuing to build this fascinating technology, and that has nothing to do with the price.
So we have Bitcoin, then we have Ethereum, and then there are a lot of other different currencies.
Yeah.
If it is open source, then why not a few of them can be as currency so that it will be much more clearer to people. And as I said, like the price will be vary as supply and demand.
Yeah.
So I mean, if you have lots of those currencies, and then you can try your own currencies, and based on people's interest, you will have
Yeah.
value. So why there are so many?
Well, greed, maybe. So in 2017. Oh yeah, sorry. So the question, as I understand it, is like, why are there so many currencies, right? So in 2017, because of the boom in the price of Bitcoin and other things, and the rise of Ethereum, Ethereum allows you to create your own coin. So it's not called a coin, it's called a token. So using Ethereum, you can create your own Øredev coin, for example. And if there's enough interest in that coin and the project behind it and the team behind it, there is value. So that's what happened in 2017. Hundreds and actually about 2,000 different project teams came up with ideas to do things on the blockchain from property to finance to academic records and so on and so forth, to do different things that are powered by these currencies. And that's the reason we are at this stage. But I personally believe 90% of those projects will fail. But there are really good projects that are trying to do the best they can to transform decentralized applications. So it's just the nature of trying different things and failing and continuing to try and again. Yeah.
Last question. So blockchain is basically a technology of a distributed ledger.
Yeah.
And then why we always associate it with the currency? Maybe it can, as you said, like we can use maybe the personal IDs and the people identities or DNS, anything we can use with it.
Yeah.
Why and for Ethereum, why do we only have projects related to the financials, the money, so that they can be flourished?
Yeah. So the question is, why are all the applications financial based? Why not something else, right? The real world production tested application of blockchain so far is money. So as we can see with Bitcoin, so we are able to transfer money across borders seamlessly. But all of these other things are still proofs of concept, you know? So unless and until it's actually proven in production, it's not going to work. So the idea is, I don't think it will never work. So, but the only thing that has worked so far is money, and that's why finance is the biggest use case for blockchain. But there are other use cases that are being worked on, and hopefully in the future, when production systems embrace blockchain technology, that will be another proof of not just finance, but other applications coming on into the fore. Okay, thank you so much.